Hello everyone, my name is Muhammad Mustaqim bin Muhammad Nazri, and today I will be presenting our group project on subjects Fluid Mechanics 1. This is our lecturer, Dr. Nasrul Hadi bin Johari. And this is my group members, include myself, Hadi and Khairul Anwar. This is our problem statement where we must solve the given question related to fluid subtopics. We had to choose to solve the flow measurement question. We get some information about the formula and calculation about flow measurement, and this project clearly to increase our knowledge in fluid mechanics. This is our objective, which is to choose any question given, analyze problem in pipe flow, flow measurement and dimensional analysis, function as an effective team member in solving problem related to fluid mechanics, and presenting the project. This is our project scope, which is related to the objectives. And this is the literature review. Literature review is a body of text to review the critical points of current knowledge and methodological approaches on a particular topic. So this is like a secondary sources of any project. And this is pitot tube. Pitot tube is a flow measurement device used to measure fluid flow velocity. And it is widely used to determine the airspeed of an aircraft, water speed of a boat, and to measure liquid, air and gas flow velocities in certain industrial applications. That's all from me, thank you.
Assalamualaikum, my name is Hadi bin Mazhar, ID number SMA 114. Today I'm going to present to all of you about our methodology from our group project. So we solve the problem that is how to measure the velocity of water flow in the river by using the flexible straw and a ruler. So to solve this problem, we're using the concept of the pitot tube by bending the straw to 45 degree and put the straw into the water flow in the river and make sure the river is laminar flow, because just laminar flow that we can apply the concept of the pitot tube. So after that, we can see that the flow will stop in the straw at certain point. So we measure the point by using the ruler and we substitute into this equation. So after that, we assume that the static pressure is 0. So we calculate directly the head of the water flow in the straw, and we get the reading, then we substitute into the equation, then we will get the velocity of the water flow in the river.
Design and discussion, we have two steps to measure the water flow velocity in a river. Firstly, we assume that the energy is conserved and not lost due to friction. We bend the straw at a 45 degree and submerge a portion of the straw parallel with the current into the water. The other portion of the straw should be exposed in the air and at a 45 degree also. The water will travel up the straw until some point, and the maximum height that the water level reaches can be measured with a ruler. And for the second step, if the water velocity in the river is V, and we can get the equation V cos 45 equal to V per square root 2. Now we consider at the maximum height. Maximum height has no kinetic energy, but it has potential energy, is equal to mgh. Water entering the straw has no potential energy, but it has kinetic energy. Kinetic energy is equal to 1/4 mv squared. These two expressions must be equal, which is mgh equal to 1/4 mv squared. And finally, we simplify the equation, we can get V equal to square root 4gh. So we can get the water flow velocity. For the conclusion, we back to the Bernoulli principle. State that an increase in the speed of a fluid occurs simultaneously with a decrease in a static pressure or a decrease in a fluid potential energy. This principle also can be derived from the principle of conservation of energy. That's all. Thank you.